Alright, so this is Unit 2, Day 3, August 23rd. Again, it's more of the same. It's still power rules. So tomorrow we'll do, or Thursday we'll do trig rules, so that's completely different, but we'll worry about that later. Let's make sure we got the power rule thing down. Find the slope of the line tangent to the curve. That's a long, long way to ask for what? The derivative. So we'll try to use all the different words we can frequently, just so that you're used to seeing it's all the same thing. In fact, that's all first semester is take a derivative. We just come up with a bunch of different ways to ask for it and a bunch of different functions to take the derivative of, but you're pretty much just taking the derivative all semester long. Alright, this is ugly. We need to do some algebra first. So, let's see. In fact, let's pick on some people here. So it looks like I need 3 to get started here. So, Tibet, tell me what the 4th root of x cubed is as a power, because I want to use the power rule, so I got to change it all to powers.
I'm not sure.
Okay.
Wait, for the 2x11 or the...
Sorry, yeah, 2x11, I already did that one. There's nothing to do on that one. I need to know what the 4th root of x cubed is. This is the power grows on top and the root grows underneath. Flower power, root. That helps. Somebody help him out. What's the power going to need to be? 3 over 4. So, good job, Nick. You're still on the clock. How about 6 over x to the 5th? How could I rewrite that as x with a power? 1/5 would be the 5th root. But 6x to the 5th is not the same as 6 over x to the 5th. Why is that x to the 5th in the denominator? What would send it to the bottom? Negative. McKenna, how about x to the 7th root of x squared in the denominator? How could I?
14x to the negative 7.
Got it. 14x to the negative 2/7. Okay, why don't you take a moment? This will be good practice, review, warm-up kind of thing. Find the derivative of each of those 4 pieces. So those are good answers, but make sure you tell me when you've switched from g to g prime, because that's the whole point of the problem is what's the derivative equal to. So good work on that. By the way, the algebra step was harder than the calculus step, at least based on the popsicle sticks we pulled. Number 2, consider the function given by this thing. What is the slope of the line tangent? What is the derivative of f of x when x is 1/3? Okay, well, I'm not allowed to take derivative of top and derivative of bottom separately. I need to rewrite this after I divide each piece by x. So let's divide each piece by x. There's 3 pieces. So we don't need time on this one, I don't think. Isaiah, what's 6x cubed divided by x? 6x squared. Andrew, I think you got the easy one here. What's 8x over x? 8. Preston, you got kind of the hard one here. What's 3 over x?
0.
Not
I
0.
would have put.
3 over x. How could I write 3 over x as x with an exponent?
Negative 1.
Yes, 3x to the negative 1.
Still
Okay.
put 0.
Algebra first. Now I'm going to press pause and have you try to do the derivative of each of those pieces. So those are the derivatives of the pieces. I intentionally made a small but significant mistake in what I've
Plus.
written down. What's not quite right about that?
Minus 2. It goes plus 3x to the negative 2. Because
No, this is right. Multiply the negative 1, so this is right.
F
I didn't write f prime. So it looks like f of x equals this, but that's not true.
That's yucky.
F prime equals that. So make sure you're clear when you've got a derivative versus when you've got the original. Number 3. Find the values of x at which the graph of this thing has a horizontal tangent line.
Mr. Wolf, on the last one, you think you're wrong on the last one.
Uh-oh, you think I'm wrong on the last one?
Because you're supposed to plug in to find.
Oh, yes. Thank you. Got so excited to get the right answer, I did not plug in when x is 1/3.
Points taken off.
Absolutely. So let's plug in 1/3. 12 times 1/3. Handle that. Uh-oh, 1/3 to the negative 2. Well, negative flips it over. 2 squares it. 3 times 9. And I'm out of room, and I'd like to make use of the safe stop, so I'll stop there. I don't want to mess up 4 minus 27. I mean, it's not hard, but why bother if you don't have to? Good catch on that one. I didn't read the full problem.
Always read the full time.
I know, and especially in calculus, you should go back and reread the question when you finish to make sure you answer the question that they asked, because that kind of thing happens a lot, where you start and it takes some work to get the derivative, you think, got it, figured it out, and you didn't go back, or I didn't go back and make sure I answered exactly what they were asking for. Number 3, find the value of x at which the graph has a horizontal tangent line. Okay, well first just show me with your arm what a horizontal line looks like. Start at the very, okay, good job. Everybody give me one of this. What's the slope of one of these?
0.
0. So tangent line means derivative. Horizontal means slope equals 0. So we want to see where the derivative is equal to 0. But before we do that, we need to divide all the pieces by x squared. So let's divide each piece by x squared. So there's what we get when we divide each of them by x squared. We wrote them as powers because we want to use the power rule. So we've got to have everything as powers. And so you guys are already taking the derivative of that. So take a couple seconds to take the derivative of that. And then we'll get 3 more people to give us some answers. Good work. We're not done yet. Paying attention this time after I messed it up last time. That's the derivative. I want to know where that is equal to 0. So I'm going to rewrite this now as 4 over x squared plus 4 over x cubed equals 0.
Now what?
Now what is right? So I'd like to solve for x. What could I do to start to get x by itself? It's kind of a... Let's get it out of the denominator first. What could we multiply by to get it out of the denominator?
Get what?
Get x out of the denominator.
X to the 5th?
That would work, but that would be overkilling it. What's the smallest power of x I could multiply by? That would cancel all my denominators.
3rd?
X to the 3rd. So that would be 4x plus 4 equals 0. So I could factor, or I could just move the 4 over, probably be easier. So x equals negative 1 is the x value. I'm checking to make sure I answered the right question here. The x value where the graph has a horizontal tangent line. Because when x is negative 1, my slope, my derivative, is 0. So there's a horizontal tangent line at x equals negative 1. Number 4. Consider the curve given by that thing. At what value of x is the slope of the tangent line equal to 2? Tell you what, why don't you see if you can take this one start to finish? What do you want to do next?
Give up. Take some sort of root. I don't know.
Factor. So you were on the right track. What could we factor out? Factor out an x cubed. Now we're getting somewhere, because now we can set each of the factors equal to 0. So x cubed equal to 0. That would mean x equals 0. So there's one of our answers. The other answer, 4 minus 27x squared equals 0. Let's see. I think I would move the 27x squared over just to make it positive. So x squared equals 4 over 27. And then we'll square root both sides. And we don't have to simplify square roots, because that's not a calculus thing. Oh, wait a minute, though. I said there's 3 answers. Why do I only have 2 answers? Plus or minus? Let's make sure we answered the question. Consider the curve. At what value of x, so we want to give x values as our answer, is the slope of the line equal to 2? So yeah, we took a derivative, set it equal to 2, and then it was algebra after that.
Yeah, tons of fun. Calculus
is easy, algebra's hard. Alright, number 5. We haven't done one quite like number 5. Write an equation of the tangent line. Alright, this was supposed to copy on to the top of the next page, so I'm going to start it over there. Find the equation of tangent line to g of x equals 2x squared minus 4x plus 5 when x equals 3. Two x cubed?
What?
I think it's 2x squared. 2x squared. Alright, okay. Equation of a tangent line. If you want the equation of a line, let's just go all the way back to Algebra 1. What do you need?
A slope.
A slope. So if we want a line, we need a slope. And what else do we need?
A point? 2 points?
So there's a couple different answers. You could say the y-intercept, because then you could write the slope-intercept form. That'd be nice. It's not really going to work here. You don't need a slope and 2 points. If you had 2 points, you could get the slope from that. So really all you need is a slope and a point, because there's a form of a line that you probably forgot about.
Vertex?
The point-slope form. This is the form we'll use in calculus almost exclusively. Y minus y1 equals m times x minus x1. That's a big deal, because we will use that often. Because it's pretty straightforward, I just need a point. That's usually not too bad. And now we know how to find slope, because slope is the same thing as derivative. And for this particular problem, it would be the derivative at 3. The point would be, well, we have the x value. The x is 3. And the y value would be the function at 3. So kind of laying it out for what the pieces we need for this. So I guess let's do the point first. That should be easy one, or easier. Oops, I said f. It should be g, because the function's name is g. So g of 3, if I want the y value, all I have to do is plug in 3. I don't need a derivative yet, because I just want the point. So let's plug in 3. Let's see, 2 times 9 is 18, minus 12 plus 5. 6 plus 5 is 11. So my point is 311. That's not my answer yet, so it's not like the final box thing, but that's a big chunk of what I need. The other piece that I need is the slope at 3. So g prime then, maybe we'll get through everybody today. I don't know. That person is in, no, that's right. Brooke, put you on the spot. What's the derivative of g of x?
4x minus 4.
Very nice. 4x minus 4. But I want that when x is 3. So how do I figure out the slope when x is 3? How do I figure out the slope when x is 3? Just plug in 3. I want slope at 3. So 12 minus 4 is 8. So there's my slope. So I've got my point and my slope. Now I'm ready to go. So y minus 11 equals slope 8 times x minus 3. And you can leave it in that form. You do not have to put it, you don't have to solve for y. You leave it in that form. Number 6. Write an equation of the tangent line. So again, I need point and slope to the graph of y equals 18 over the 4th root of x when x equals 16. So the point is 16 comma something. And the slope would be f prime at 16. So how do I figure out the y coordinate of the point?
Solve.
Just plug in 16 for x.
Did you mean to write slope for f prime?
Yeah, because the slope is f prime at 16.
But at the last one we did regular g.
Not for slope. That was g prime. The point was g, but the slope is g prime. And that's an important difference the whole way through. The point is the function value. The slope is the f prime value, the derivative value.
Oh, okay.
So f of 16, 18 over the 4th root of 16. Let's see, the 4th root of 16 is 2. So they made this manageable anyway for us. So the point is 16.9. F prime, that's going to take a little work because I need to do algebra first here. So Kyle, how can I rewrite the fourth root of x in the denominator as x to some power? Wait, the root is just the power of 1/4. So x to the negative 1/4. I haven't taken a derivative yet. I need to make it a power and then take a derivative. So f prime 18 times negative 1/4 times x to the negative 5/4. Oh, this is going to be yuck. So I need to plug in 16, but I don't really think I want to plug in 16 yet. I want to keep cleaning this up here. So negative 9/2, and then 1 over x to the 5/4. It's going to be lovely. But it's just algebra. That's not even algebra. That's just plugging things in. 16 to the 5/4. 16 to the 5/4. Well, we already figured out the fourth root of 16 is 2.
Yeah.
And then 2 to the 5th
32?
is 32. So negative 9 over 64
Is that safe stop? You don't have to simplify?
is my slope. Yeah, I didn't even pause to think if that will simplify. I don't think it does, but even if it did, you don't have to reduce fractions. So if you really wanted to, you could have stopped right there. Actually, you could have stopped one step further back than that. Thank you. So point slope form of the line. That might be the most important new thing you learned today. It's not new, but most important thing you relearned today. Y minus y1 equals slope times x minus the x point.
Yay.
Number 7, relative extremum.
A maximum?
That means maximum, or extreme means either extreme. So what's the opposite of a max? Would be a min. So let's think about what that would look like. There's a max and a min. What? Ask a question that you could answer without making it too easy. I guess I'll go with the easy one. Well, maybe it's easy. Do you think you know the slope of the tangent line at the max? The slope of the tangent line at the max. 0, because that tangent line is going to be sitting right about there with the slope of 0. How about the slope of the tangent line at the min? Also 0. So
okay.
If f prime is 0, you might, this gets to be a little bit tricky later, you might have a relative extrema. The might comes a little bit later, but for now, we can say if you're at a max or a min. No, I can't say that because it might be a cusp. There's a connection between slope is 0 and having a max or a min. It's not always a one-to-one connection, but it's pretty close. So let's take a derivative, and what do you think we should do once we have the derivative?
Set it equal to 0.
Set it equal to 0. Austin, how about telling us the derivative of that function?
It's 12x squared plus 4x.
Good. I wrote it as dy dx just because I like to mix up how we write derivatives just so that we stay familiar with all of them. We'll set that equal to 0. And we can factor out a 4x. So at x equals 0 and at x equals negative 1/3, we probably have a max or a min. We're not far enough along yet to know which one is which or how to tell, but there's a slope of 0 there, so something's going on when the slope is 0. All right, 8 through 12. Got a picture. So this should go quick if we understand what these things represent. What values of x satisfy f prime equals 0? Well, derivative is another name for what? Slope. Like those two words should stick in your brain together. Slope and derivative. Slope at a point is the derivative. The derivative tells you the slope at a point. So when we phrase it like that, what x values have a slope of 0?
0 and n p.
I would say x equals 0, x equals n, whatever that is, and x equals p. Okay, now we're going to be doing this kind of stuff all year. On what intervals is f prime less than 0? So let's see, that means slope is less than 0.
Negative slope?
Negative slope. What's the function doing if it has a negative slope?
Going down.
So that would mean f is decreasing. And that says interval, so not just a specific value, but an interval where x is decreasing, or not where f is decreasing. So that looks like it's going down from 0 to n, because we want the x values. So from 0 to n, and p to infinity. Now, weeks, hopefully not months, from now, when you see f prime is less than 0, your brain is automatically going to think, oh, that means f is decreasing. For now, though, it takes a little more methodical thought process here. If f prime is greater than 0, okay, that means the slope is 0, or greater than 0. That means f is increasing. So let's see. Marissa, how about a interval where f is increasing? That's an okay answer. I'm going to assume that goes on forever. So I'm going to go negative infinity to 0. Brandon, where else is f increasing? From n to p. Like that.
Does it matter if you write and or the u?
I mean, u is more fancy, but and is okay. U would be probably better. On which intervals is, two things here. F positive and f prime negative. So I'm going to rephrase that as f is decreasing. So I want the function to be positive. So that means, above the y-axis, or excuse me, above the x-axis, but also decreasing. So where is my function positive, but going down?
P to 2.
P to 2. Just kind of have to put two things together there. On what interval is f negative So below the x-axis, but f is increasing. So f is negative, but we're going up. So negative infinity up to 0.
And n to 1, yeah?
Oh yeah, I almost missed that one. And n to 1. Good call. Good call. All right, today's assignment is the worksheet next. Worksheet 3, I think. So we didn't do anything new today, or we kind of did some stuff new, but mostly based on stuff that we kind of already know. So just more practice on derivatives. Oh, we'll probably have a quiz tomorrow. How about that for some fun? It'll be a short, multiple choice, low impact, meaning it'll be graded, but not graded, but not weighted. Weighted, but weighted small, I should say.
Basically, one month class. Yeah, you're not supposed to experiment on it. And when people Thursday. See you Thursday.